Welcome. Let's try to solve another Leetcode problem 2972 called the number of incremovable subarrays. So for this problem, let's just check the example. So from the description, we know that if we are having an array of like 5, 3, 4, 6, and 7, so because we can remove this subarrays since it's the array, so we can remove some subarray like 3 and 4. So after removing 3 and 4, what's left behind is 5 and 6, 7 inside of the array, so which is strictly increasing. So we're going to return the number of incremovable subarrays of nums. We just want to count how many subarrays we can remove. What's left behind going to be a strictly increasing array. So for this example, like 1, 2, 3, 4. Because this is strictly increasing already, we can remove any one of them. We can even remove like the whole array, like 1, 2, 3, 4. What's left behind is just an empty array. This also counts. So how many of them? So definitely for this example, it's going to be n times n plus 1 divided by 2. Because if we remove all of them, we're going to count it as 1. But what if we remove 3, like 1, 2, 3, or 2, 3, 4, it's going to be 2. So, but what if we remove like 1, 2, 2, 3, 3, 4, it's going to be a 3. But what if we remove a single number, like 1, 2, 3, or 4, so it's going to be 4. So in total, it's going to be 10. So we're going to have a mathematical formula. It's going to be n times n plus 1 divided by 2. So if this array is strictly increasing, like the first example. But for most of the cases, the array is going to be something like a curve. It's going to be something like this. So let me just give a very basic example. So let me just use this example. So inside this example, definitely the array is not strictly increasing. There's going to be a curve at some areas. It may be several curves, but I just draw one curve because this is just for explanation. So from the left side, we are sure we're going to start from index 0, and from the right side, we're going to have an index n minus 1. So let's just set from the left side, we're going to use index I. So if from the left side this is increasing, we're going to update as I. So we're going to update as I until to on this place. So for the next place, definitely we cannot update I because it is not strictly increasing, because up to here, 0 to here we can update as I because it is strictly increasing. But while we update to this point, so definitely we can calculate how many subarrays we can remove. So after that, the array is going to be strictly increasing. But how can we remove that? So we're going to remove it from I plus 1. So this point going to be I plus 1. So after removing the right side, so what left behind is this curve. Definitely it is strictly increasing. So we're going to count it as 1. So this is I plus 1. So what about I? So after removing I, so what left behind is strictly increasing. After remove some areas, so what left behind from the left, definitely it's going to be strictly increasing. And how many of them? We're going to just remove like from index 0 to I plus 1. So how many numbers? 0 to I plus 1. Definitely it's going to be I plus 1 minus 0 plus 1. So it's going to be I minus 2. So the number of remove going to be I minus 2. But this is only one case. We are sure that we're going to remove for all those points. It is possible because what left behind is strictly increasing. But this is only for the increasing areas. But what about other areas? Is that possible? So what about we just count from the right side? So what we left behind is n minus 1. So this means we're gonna remove from here, from n minus 2 to maybe we're gonna remove to I plus 1. So we're gonna remove this part in the middle. After remove, it's gonna be strictly increasing because at this position nums I gonna be so from the right side we're gonna set it as j. Yeah, let me make it better. So from the right side we're gonna use the index j. So from the left side nums I gonna be less than nums j here, so j gonna be n minus 1. Yeah, so if at this position nums I is less than nums j, so definitely if we remove these areas in between, it's gonna be strictly increasing. Yeah, so what left behind is we're gonna include this number at nums j, and what left behind is we're gonna include all those areas from 0 to I. Yeah, so how many cases? Definitely we can remove. Yeah, we can remove from this position to I plus 1. So definitely it is possible to remove from this position to I minus 1 until to 0. So how many of them? It's gonna still be I plus 2. Yeah. So if this dot is possible, we're gonna plus I plus 2. If here this is also possible, we're gonna plus I plus 2 until this is possible, this is possible, all of them are possible. Maybe it comes to some other places, maybe here. Yeah, maybe here that is not possible because we're gonna check the we're gonna check the pointer of I. So from here we're gonna set it as the let me think about it. We're gonna just use the pointer I. So from here we just use the pointer I, and while from here we're gonna use the pointer j. So j coming from n minus 1 and j gonna be decreasing until to here. While it goes to here, it is not possible. So if it is not possible, what's gonna happen? So we're gonna decrease the I. We're gonna decrease it to some other places. Maybe from here, maybe just an example, maybe I minus 1. From here, that is possible because the nums I minus 1 gonna be less than, here gonna be j, less than nums j. Yeah. So this means we can cut in between. We can cut from j minus 1 to here to I. Yeah, j minus 1, I to j minus 1. We can cut between these areas. Definitely it is possible. Yeah, if we can cut from I to j minus 1, then we can cut from I minus 2 to j minus 1, and we can cut all of them. Yeah, because we are updating the I all the time. So at the moment, this gonna be this dot gonna be the I. Yeah, so this means definitely we can cut from the I until we can cut I plus 1, I until to 0. So this is another of I plus 2. But this I plus 2 is updated with the decreasing of I. Yeah, so definitely whether we calculate from here or in between, we're going to use I plus 2. Yeah, so this is the idea, because what left behind is that the array going to always be increasing. So this means we can cut from one side, or we can cut it in between from the middle. Yeah, while we are enumerate this j, actually we just enumerate all the different cases. Yeah, for one case we just check from the left side. It is possible because we're gonna cut from these areas. After that we're gonna just enumerate this index j, and we're gonna check how many possible cases, and we just code them in total. Yeah, maybe the coding gonna be much clearer. Let me use n gonna be the length of the nums, and I'm gonna use the two pointers I and j. So I gonna be 0 and j gonna be n minus 1. Yeah, I don't need to use j at the moment. I'm gonna use I. Yeah. So while I is less than n and nums I less than nums I plus 1, because this is going to be strictly increasing. So since I'm going to use I plus 1, so here I'm going to use I plus 1 less than n, otherwise it will go out of the boundary. So I'm going to update the I. Now I'm going to check this I. If I equal to n minus 1, so definitely I'm going to have a return, because this is strictly increasing. So I'm going to use n times n plus 1 divided by 2. Yeah, so this is one situation. Luckily for the first example, we're going to directly have a return. Yeah. Now let me give a random return 0 to check if the first testing case works or not. Yeah, as you can see, the first test case works because it is strictly increasing the number going to be 10. Yeah. Now we're going to check other cases. I'm going to prepare a result. It's going to be I plus 2 as I calculated before, because finally we're going to use I plus 2. Yeah, because they're going to be I plus 2 removals of the subarray. Yeah, so this is going to be from the beginning, and J going to be starting from n minus 1. And now I'm going to enumerate the J from the right side. So from the right side, I'm going to enumerate J, and I'm going to check how many different cases. Yeah, so I going to be the same as before we calculated the position of the I. So I going to be here. This is the position of I, and J going to be here. Then we're going to enumerate the J from the right to the left side. So while J equal to n minus 1, so this is one case, or nums J yeah, gonna be strictly less than nums J plus 1. Yeah, so if J is at this place, because we're gonna use this index J. If J is at this place n minus 1, definitely it is possible. Or at another place, J may be at n minus 2. Yeah, if J equals to n minus 2, so J plus 1, it's gonna still be n minus 1. It's gonna be inside the boundary. So this is why we're gonna use J and J minus 1, because we're gonna use this index J as our final position. Maybe this gonna be, yeah, this J gonna be the final position, and then we're gonna use this dot for the final calculation. Yeah. So if it meets the condition, definitely J gonna be minus 1, and the result gonna be plus equal to I plus 2. Yeah. But for this situation, that is only for the position nums J gonna be more than the nums I. Yeah. But what if it is not more than? Definitely we need to use yeah, like a sliding window we needed to slide, or like two pointers we needed to shift the pointers. Yeah. So here we're gonna check the I. So while I more than equal to 0, and nums I is normally nums I should less than nums J, but if it is more than and equal to nums J, so this means we need to update the I. So I gonna be shifted to the left side. Yeah. So in this problem, we shift the J pointer go to the left side, and the I pointer also go to the left side. They must be in the same direction, because only in this way it's going to be O(n) time complexity. Yeah, because for the J pointer it will always go to the left, and I pointer will always go to the left, because it is monotonic. So this means we can use yeah, this kind of two pointers to solve the problem. Yeah. Finally, we're gonna return the result. Yeah, I think that's all about it. Let me just run it and check if it works. As you can see, it works. Now let me just submit it. Yeah, because we are using two pointers, so the time complexity is O(n) and the space complexity is O(1). Yeah. Let me analyze a little bit about this areas. Maybe this is a little bit hard to understand. Yeah. Yeah, so the basic pattern is that sometimes it is not strictly increasing, like the first example. It's going to have some curve. Yeah, so from the left side, we're going to update the pointer. So the pointer is going to be updated from 0 to this position. So this position is going to be I. And from the right side, this position is going to be J. Yeah, so for these areas, actually, we're going to shift the right pointer, go to the left. And for this I, we also want it to go to the left in the same direction. Yeah. Now we're going to check this point. So if the value of this point is more than the value of this point, what's going to happen? Yeah. So what's going to happen is that we want to cut something from the right to the left. Yeah. So we want to cut it from here, and we want to cut it from here. So this point is going to be I plus 1. So after this cut, definitely what left behind, it is strictly increasing because this part plus this part, this dot, is going to be strictly increasing. So what about we just shift it to another position, maybe here? And it is still, yeah, let me just go back. Yeah, so this is okay. So this is one position. So what about we cut it here? Because this is in increasing order, so if we cut it from here, so this distance is another possible result, because from here to here it is still increasing. So what about we cut here, cut here, cut here, cut here, cut all of them? It is always increasing after cut. So that is why we're going to use I plus 2, because in total there's going to be I plus 2 cut. Yeah. Now let me just go back. Yeah, so this is we didn't check the while inside the inner loop. Yeah, we just check everything is okay. But what happens is that after shifting this j, at some point the nums j going to be less than or equal to nums I, maybe at this place nums I. Yeah, what happens if it happens like that? Definitely it is not possible, but we can update this I. Maybe I going to be, we're going to set it here. If we set it here, maybe nums I going to be less than nums j. Yeah, so this is j, this is I. So how we going to calculate how many cut? So definitely from here, we're gonna, yeah, so this is j. So definitely we're going to cut from here. It's going to be j minus 1. And from here, it's going to be I plus 1. This is going to be the first part, I plus 1 to j minus 1, then I to j minus 1. So in total, it's going to be 0 to I plus 1. So how many points? It's going to be I plus 2. Yeah, this is why we're going to use I plus 2. And then we're going to continue. And this j going to be shifted to this position. So this is going to be the j. Yeah, because after that, definitely we cannot shift j. Yeah, so do you believe after that we can continue to shift the j? Definitely not, because here is a control inside of the outer loop. It's going to be always in increasing order. Yeah, so this is going to be another point to check. So this is going to be the j, and what's going to be I going to be here maybe. Yeah, so another point is going to be j minus 1. So j minus 1 going to be here. Yeah. So we can cut from j minus 1 to here, I plus 1, and to I until to 0. So how many points? It's going to be 0 to I plus 1. So it's going to be I plus 2 points in total. So this is why we're going to use I plus 2. And this is why inside the outer loop, we're going to use j plus 1. So if you use j minus 1, if you use nums j more than nums j minus 1, so you are missing the count of one dot. Definitely it is not possible. Yeah. I think that's all about it. Thanks for watching. See you next time.